Hi, it's time for another math easy solution. Turn to discuss polynomial long division and now look at what happens when we deal with multiple variables. Basically, in my earlier videos on polynomial long division, I only covered examples that involved a single variable, such as this example right here, which we're dealing with just one variable, and that is, well, the x variable right here. So that's just one variable. And you can see how I solved this in my earlier videos in the video links below in the description. And now, well, for multivariables, the process of polynomial long division works basically in the exact same way as we would do with single variables. But this time we will be dealing with terms that contain multiple variables. So basically we could apply the same process. And I'll go over this example on that, which is right here, x squared plus 2x squared y minus 2xy plus 2xy squared minus 3y squared, all divided by x plus y. So as you can see here, we are dealing with two variables, x and y, but we could do basically the exact same thing. So the first step in using polynomial long division is just writing this out like this. So we write the denominator on the left side here, we put this quotient symbol here, or the division symbol, and now we put the numerator inside. So x squared plus 2x squared y minus 2xy plus 2xy squared minus 3y squared. And now the process here is exact same as for single variables. First thing you have to do is find a variable to multiply by this x plus y and to equal x squared. Well, at least having one term with x squared. So in this case, we've just put an x, because x times x, that's x squared. Now x times y right here, yeah, x times y is basically, well, xy. So we would put that underneath the term that has an xy. In this case, there's no x squared y, so plus 0. Now we plus, well, xy underneath this negative 2xy. Let's erase this. And now we just subtract. So now we subtract this entire thing. Yeah, subtract this from this entire bar on top. We'll get this x squared minus x squared. That's just 0. And now we have 2x squared y minus 0. That's just, well, 2x squared y. And now negative 2xy minus xy. That just equals 2, well, 3xy. And now we add these back down here. We're not subtracting them from anything, or this minus 0 is just the remainder, exactly what this is. So we add these here, 2x y squared minus 3y squared. So now we have this. And we keep doing the exact same process. So now we multiply this x plus y by something that gets 2x squared y. And in this case, that's just going to be, well, there's an x and there's a y and there's a 2. So we put 2xy. So when we multiply 2xy with x, we get 2x squared y. Yeah, and now when we multiply by the y, so 2xy times y, that's just, well, there's no xy term in this case, but we have a 2xy, yeah, y squared. So we have this term right here. Now we just subtract this out, and we get basically the exact same thing. So this 2x squared y minus 2x squared y, we just goes to 0. Now negative 3xy minus 0, that's just going to be 3xy. And now this 2xy squared minus 2xy squared, that cancels out. So we get a 0 right there. And now we will just be 0. And now we just put the remainder here, which is negative 3y squared. So we go negative 3y squared. And now, so that we have this, now we keep doing the exact same thing. We need to multiply a variable over here by x to get negative 3xy. So we would do, well, negative 3y. So negative 3y times by x, that's just negative 3xy. And now negative 3y times it by y, that's just negative 3y squared. And now we subtract these out. So when these are the exact same terms, so these cancel and those are 0. So what this means is the answer is this top one, and there's no remainder right here. So I'll write that down. No remainder left over. So put this all together, what we get is this entire function right here, or this fraction right here equals 2, and then we just put this answer on top, which is again equal to x plus 2xy minus 3y, and that's it right there. So this is what this equals using polynomial long division. Anyways, that's all for today. Hopefully you learned from this example, and I just wanted to show that it doesn't matter if you have one or two or more variables, you could use the exact same process. Anyway, that's all for today. Like always, you could download these exact notes in the link below, and stay tuned for another Math Easy solution.